Now this video is it's going to give you the solution to the problem number 19 in the final review in my open math. And this question 19 starts out, the solution of it starts out pretty much the same as question 18 started out. In other words, first we're going to need to find all the rational zeros that go with this term here. It's a term that has a degree of 3, and we're going to find all the rational zeros. Now, I'm going to do that kind of quickly because I gave a more detailed description of the process in my video about question 18. So please take a look at that if I'm going too fast when I say that the rational zeros, get a good pencil here. The rational zeros for x cubed plus x squared minus 8x minus 6. The rational zeros are these, plus or minus 6, plus or minus 3, plus or minus 2, and a plus or minus 1. Now, of course, as you saw in my video for question 18, the way I got that was to form the ratio between the coefficient of the constant term, or the constant term itself is a 6, a negative 6, divided by this is a 1 here, you could say. The coefficient of the leading term is a 1. So these are really fractions like plus or minus 6 over 1, plus or minus 3 over 1, plus or minus 2 over 1. But I don't want to go into any more detail about that because, as I say, that's explained in the video for question 18. And I'm already up to 2 minutes here. Now, what we're going to do, we're going to take all these possible zeros here and try them out and see if they actually are solutions for this. As to say, if we were to use long division, we could take, say, x minus 6 and divide it into the cubic term here. And we could take each one of these possibilities, x plus 6, which is the same x minus a negative 6, and divide that by long division into that. But we're not going to use long division. I'm just showing you how we're trying, since we say that one of these numbers is a root, that means that if we divide this term by x minus that root, they would factor into it. Now, instead of long division, though, let's use synthetic division, which is another more convenient way to try out all these possible values of x. Now, one thing I need to point out here, I tried this problem without the camera being on, and I found that this number here, negative 6, I need to change it to a plus 6 because actually if I left it the way that my open math gave it to us as a negative 6, there are no, none of these work. None of these possible zeros was a solution of this when you used it as a negative 6, like it says up here. I found I had to change that to a positive 6. Now, having done that, we're going to use synthetic division. We're going to change this all the time to a plus 6. And synthetic division works like this. You take the coefficients. Let me write this as 1x squared. So the coefficients of this term here are these: 1, 1, a negative 8, and 6. And synthetic division works like this. We're going to try out, say, see if 6 works. We're trying to find out if 6 is really a root. We know it's a possible root, but we'll try it out with synthetic division. Here's our synthetic division now. We set it up like this. The first thing we do, bring down this 1, multiply. 6 times 1 is 6. Add these. 1 plus 6 is 7. Now we multiply. 6 times 7 is 42. And 6 times 7 is 42. And then we add these two numbers. 42 minus 8 is 34. Wow, we're getting up into some pretty big numbers. Obviously, this is not going to be one of the ones that work here. I could use my calculator for this. 6 times 4 is 24. So this is 204. Obviously, we don't have a remainder of 0. We want to get a 0 here. Now, another number we could try. Well, I know because I did this outside the camera. I just was holding off getting to the correct answer because I wanted to show you a few examples of synthetic division. I'll try another one. The next one we try should be really a -6, but I know a -6 is not going to work. Let's skip over to 3, see what happens when you use 3 and see if that's a root. The coefficients remain the same every time you try this. Bring down the 1. 3 times 1 is 3. Now we add these. 3 times 4 is 12. 12 minus 8 is 4. 3 times 4 is 12. No, see, that's not going to work. Well, I know because I tried this. Which one is going to work? Let's go to the 1. This is the one that works is 1. X equals 1. So we'll put our coefficients. It's just that when I tried this before outside the camera, the first one I tried was 1. And that right away it worked. So, well, that's no fun because I wanted to show the audience some examples of synthetic division. And if the first one worked, I didn't think that was... Oh, wait, you can't see this now. I'm just made it in time to move this up so you can see it. Sorry about that, but I'm not going to start the whole video over again. I tried 6, I tried 3, they didn't work because we got numbers. We didn't get a 0 here. But 1, let's try 1. Bring down this 1. 1 times 1 is 1. Add these. 1 plus 1 is 2. 1 times 2 is 2. And then we add these. 2 minus 8 is a -6. We multiply this. 1 times a -6 is a -6. And we add these. Voila, we got a 0. That's what we want. And that means that 1 is a root of the equation. And that means that if this here gives us the coefficients. In other words, this is the coefficient of the x squared term. 1. This is the coefficient of the x term. And this is the constant term. That is, can you see? Oh, no, you can't quite see what I'm at. In other words, we have here the coefficients of a quadratic term. So that, and I'm going to continue this on the next page, but x minus 1 times x squared plus 2x minus 6 equals 0. We succeeded in factoring the big equation that we started out with at the very beginning. In other words, remember, here was the big equation, a cubic kind of an equation, plus 6. So that was the original equation. What we've succeeded in doing now, we've factored it so that x minus 1 times this quadratic term will give us 0. I'm going to stop this video because it's become almost 10 minutes long, and I'll continue it in part 2.